Okay, now some applications need the performance, real-time performance of an embedded system, but they need the I/O performance of an instrument. And one such application is passive radar. Let me explain to you a little bit how it works. So in a normal or traditional active radar system, you emit microwave pulses, and those reflect off of the target, like an airplane. And you receive them, you do some measurements, and you can determine the location and direction of that target. Now, there are some drawbacks to traditional radar systems. Most notably, because you're emitting pulses, they can be detected and even jammed. Now, in a passive radar, you don't emit anything. In most parts of the world, there's plenty of RF signals bouncing around from TV and radio. And objects like that plane passing through that RF field cause very, very small disturbances in those signals. And if you have the right receiver and a whole lot of signal processing and math, you can actually detect those changes in the presence of all of the other RF signals and ascertain the same information as a traditional radar system. Now, the theory of passive radar has actually been around for many decades, but it wasn't realizable because of all the processing capability it required. Well, thanks to Moore's Law and system design software, this is now a reality. Researchers at SELEX, Sistemi Integrati in Italy are at the forefront of this field. They've designed, prototyped, and deployed a working passive radar system based on LabVIEW and our PXI hardware products. We have a video, let's show you the application.
My name is Riccardo Mancinelli. At the moment, I'm in charge as program manager, technical manager of the passive radar system project. Our main goal was to have processing as fast as possible. And digital down conversion, multiple digital down conversion, because we tune our system simultaneously to a certain number of stations in order to have a good target detection and localization. The reason why we choose NI product is because of the user-friendly environment to develop software and to program modules. The core of this radar is, of course, the signal processor, because we have to detect very weak echoes from targets, which are usually deeply buried in noise. So what we need is a high-speed digitizer, embedded processing capability, and we have chosen the Flex Rio modules because they have an FPGA we could use to implement the multiple digital down conversions. And we also needed LabVIEW FPGA in order to implement all the firmware we needed in the system.
Wow, okay, so at least one of the engineers from SELEX is here at NI Week, Enrico Tille. Let's give him a hand for a really amazing application of passive radar.